So this is my home, Anchorage, Alaska. It's not exactly a tech hub. In 2017, I graduated from the University of Alaska with my degree in electrical engineering. Oh, it's funny, I don't have my speaker notes down there. It's just the slides. It's fine, I have it here. After graduation, I moved down to Salt Lake City, Utah, where I landed my first drone job. At this point, I had never used Linux, I had never written any C++, and I barely knew how to code. But today, I'm one of the maintainers of PX4 and a top contributor. I've worked with dozens of companies in the industry, and I've written code that flies on thousands of drones worldwide. But I didn't get here alone. When I needed help, I asked questions, and people responded to me. When I found bugs, I submitted pull requests, and people reviewed them. And when I found myself lost in the code base, scratching my head, this community showed up for me. This talk is about that journey, about how engaging with open source transformed my career, why engaging is more important than you might think, and how contributing to open source isn't charity. It's one of the smartest investments that you can make. So this is me. In 2018, I was put in charge of a PX4 code base. I was immediately in over my head. But thankfully, my manager had a philosophy, and that was to stay close to upstream. Every week, we pulled the latest changes into our development branch, and we reviewed and did cursory flight tests of the code. And while we didn't understand everything, we learned through osmosis. And using this process, we were able to quickly identify bugs and report them back up to the maintainers. It allowed us to add our features quickly and to stay on the bleeding edge. And during this time, I asked a lot of questions online. And usually, where is he? It was Daniel Agar who would respond to me. And Daniel became my mentor. He'd answer my questions, he'd review my code, and he'd explain architectural concepts that I didn't understand at the time. On more than one occasion, I'd be sending him direct messages, totally interrupting his day, and he'd drop what he's doing, and he'd hop on a call to hash them out. And can't forget to mention the others. Biak Kuhn, Lawrence Meyer, Matthias Grob, they all took their time to give me feedback. And their feedback made me better. It encouraged me to study in the evenings and to hone my skills. And after a while, I stopped drowning, and I started contributing. By staying close to upstream and engaging with the community, I went from someone who couldn't navigate a terminal to someone who could architect flight control systems. And a year later, I went on to design my own flight control firmware from scratch, just to prove to myself that I was ready to go out on my own as an independent contractor. And at first, contracting was exciting. I was helping companies use PX4. I was helping develop companion computer applications, and we were building novel embedded systems. However, there's a common practice at many of these companies. They would take whatever the latest release was of PX4 Q ground control, they'd make some changes on top, and they'd ship their product. At first, I'd push back because I'd been taught that diverging from upstream and not staying synchronized was risky. But I had never seen the consequences of that firsthand. And I couldn't deny the development velocity that came with fork and stabilize. But fork and stabilize often meant fork and forget. I spent the next 2 years learning the hard way why forking and forgetting is a horrible idea. I ended up as the sole maintainer of a PX4 and Q ground control code base that I diverged significantly from their upstream counterparts. And at first I didn't see the problem. At this point, I accept the notion that forking and stabilizing was pragmatic. We had all the features we needed, and the system worked, and our partners, they agreed with the practice. But over time, the gap kept growing. While working at this company, we developed a number of novel solutions, things we thought were our secret sauce, things we thought that gave us the edge. And while this might have been true, we didn't realize the cost of maintaining these custom solutions. The worst mistake we made was to ship some payload hardware that had work-in-progress Mavlink messages. I had submitted a pull request upstream, but as you probably know, review takes time, and we had shipped hardware before the messages went in. But the customer was asking for it. They had deadlines. They told us they didn't care if they received prototype code. And in the meantime, the upstream definitions evolved, as I thought they might, and they changed before they finally went in. But it was too late. The customer had already deployed the payload. And the worst part is they had another partner who developed an app against these work in progress messages. When it came time to update, they didn't want to update because taking the new messages meant coordinating updates with their partners across their entire fleet. So we continued to ship the hardware with the work in progress messages. And today the hardware lives on. System integrators using the hardware need translation layers. One rush shipment resulted in permanent problems. And it wasn't just Mavlink. We had custom drivers, custom modules, custom pre-arm checks, custom mission behavior. The list goes on. When we encountered edge cases and bugs, which we did, it became a blame game trying to debug them. Was it our code? Was it the base release? Was it the third-party apps? We couldn't isolate it. And we struggled to solve the problems on our own, digging through a code base that wasn't truly our own. And we couldn't test against upstream as much as we wanted to. Our entire system was built on this old release that was at this point more than 2 years old. We were stuck in no man's land. The code base had become a pile of technical debt, and we had dug ourselves a hole. We had chosen speed over sustainability. And in the end, what we thought was the shortcut ended up being the longest path. So maybe you've been here before, or maybe you're here right now. Your code base looks like a house from Dr. Seuss. You're stuck on an outdated release, and you feel handcuffed to the old code. Maybe you pull down critical bug fixes, but nothing goes back up. You might even have fixed bugs that still exist upstream, but just haven't found time to open a pull request. But it's not because you don't want to contribute. It's because you feel that you can't contribute. The delta between your code and the upstream code base has grown too large. You wouldn't be testing apples to apples. And what's the point in keeping up with all the daily goings on in upstream when you're on an old fork? Testing upstream every week is time consuming, and you already have enough work on your plate. And I get it. You need to move fast. You have an upcoming demo, and you can't afford to fall short. You have features unique to your airframe that you feel don't fit the code base at large. And why spend the, you need features now, and you don't have the luxury of time to wait for an upstream review. You need stability and reliability from your system above all else. You're not going to ship code that hasn't undergone rigorous testing, so why spend time on upstream PRs when you're going to have to apply those changes to your own fork anyway? You tell yourself that you'll fork and you'll stabilize, and you'll synchronize later before the next release. But later never comes, and you've accepted a trade-off. And the thing is, this trade actually works. In the short term, you do save time. You're not spending hours every week reviewing changes. You're not dealing with new bugs. You're not testing against a moving target. And you're not arguing with strangers online. But there's a catch. Every week you stay forked, the gap grows. Not linearly, exponentially. A 1-month divergence, that's not a big deal. That might only take you an hour or two to merge in your changes. 6 months, depending on how many customizations you have, maybe it takes you the day. But 2 years, there's too many changes. The merge doesn't go in cleanly. Your only choice is to take the next latest release, start from scratch, and apply all your customizations on top. You hope and you pray that the new release is as stable as the last. And when a customer eventually comes knocking, asking for a feature from the new release, or there's a critical bug fix, but you can't cherry pick it cleanly, the cost of the trade-off is revealed. So what is the cost? Well, there's the obvious stuff, the stuff that I already mentioned. You can't consume the latest improvements. You can't get help from the maintainers. You're stuck supporting your custom integrations, and your engineers feel handcuffed to an outdated code base. So where was I? Something worse than all of the technical debt and all the obvious stuff. When you're maintaining an isolated fork, the code that you write doesn't receive the same level of scrutiny. There's no Biak Kuhn reviewing your driver changes. There's no Daniel Agar pushing back on your architectural choices. And without that feedback loop, the quality of your code starts to drift. You fix bugs, you ship features that work, and good enough for the customer becomes good enough for you. And something happened to me, I don't know, maybe some of you can relate to. I started making compromises. I started cutting corners. My engineering rigor began to erode. And the chaos of working at a startup makes it really easy to rationalize. But the problem wasn't just me. The problem was the process. The lack of peer review and the time pressure to ship, it makes it easier to let standards slip, one decision at a time. And here's the thing I realized. How you do one thing is how you do everything. When you make exceptions in one area, when you say just this once, or we don't have time, it becomes easier to make those exceptions everywhere. Happened to me, can happen to you, not because we're bad engineers, but because the process removes the guardrails that keep us sharp. So what can you do about it? Well, you can start engaging with upstream. Not next quarter, not after the next release, right now. When you start engaging, 3 things happen. First, you build relationships. When you hit critical issues, the core developers actually know who you are. It's more likely they're going to help you debug your problem. Second, you stay ahead of the churn. You help maintain quality and you catch bugs before they end up in the next release. You review changes that affect your use case and you keep the code base healthy instead of just inheriting whatever's there. And third, you build your reputation. You deliver fast issue resolution to your customers. You provide them with strong technical explanations to their problems and immediate solutions with upstream patches. You give them the confidence that you actually know what you're doing. Every bug you fix upstream is one less bug your customers hit down the road. Every feature you push is one less feature you have to maintain in your fork. Every code review you participate in strengthens your understanding of the system that you depend on. And this isn't charity. This is the most strategic thing you can do to secure your company's future. Contributing isn't some nice-to-have activity or something that you do on the weekends. It's the choice that separates those who use technology from those who shape it. So how do you start? Well, I'll give you some practical steps. First one, you can go to GitHub and you can click the watch button. That's going to sign you up for GitHub notifications. And yes, you're going to get a lot of emails. You can set up a dedicated inbox. It's pretty easy to do in Gmail. You can filter emails to a dedicated inbox and you skim it once or twice a week. You don't need to read every single conversation. Just get an idea of what's going on, what the issues are, what people are working on, and in what direction things are heading. Second, get on Discord. This is where most of the conversation is happening. Browse the discussions, answer questions if you can, and ask your own if you need to. And third, build a test platform. Get a small development drone just for testing upstream. It doesn't need to match your production system exactly, just something you can fly to sanity check the code base and test your pull requests. This is the bridge between your production system and the bleeding edge. Fourth, show up to the weekly dev call. You don't have to talk, you can just listen. Understand what the priorities are and get to know the maintainers. Fifth, reverse your development process. When you fix a bug, fix it upstream first and then cherry pick it to your fork. Every time you do this, you're closing the gap instead of widening it. And finally, allocate time. Give your engineers dedicated time each week to engage with the community and to synchronize your development branch. This isn't a when they have time. Set aside dedicated time. Because let me tell you what PX4 actually represents. It's hundreds of engineers spread across over a decade. Different companies, different countries, working together to build something that none could create alone. But it only works if people participate. If everyone took and no one gave back, the project dies. Not overnight, but gradually. The maintainers burn out, the code base degrades, and eventually the foundation that you built your business on crumbles. The companies that will thrive in this industry over the next decade are the ones that understand that participation in open source is their competitive advantage. When I was drowning in 2018, I could have given up. The code base was overwhelming, and the learning curve was brutal. But the help I received made me believe I could actually learn this thing. Knowing that there was a community of experts who had my back and that were committed to the maintenance of the project, it gave me the confidence to go out on my own. And that's not a small thing. I bet my career on this. Students and researchers today, they depend on the same ecosystem. New contributors to the project, they need someone to answer their questions. They need someone to review their pull requests, and they need someone to show them the way. Service members flying missions, their lives literally depend on this code functioning properly. System integrators working with this next generation of drones, they're counting on us to maintain this foundation. So here's what I'm asking. Join us, engage with the community, and help us build this technology. Become a contributor. We need your expertise, we need your perspective, and we need you in the arena. Thank you. And I wanted to just take a moment to shout out some people I think exemplify the spirit of open source. Am I over time?
Good, go for it.
Okay. Yeah, first one, Daniel Agar. Everyone knows Daniel. Give it up for Daniel. And I'll just go through these quickly. Second one is Don Gagney. I couldn't find a picture of him. Never met him, but long-term maintainer of QGC. Third, Holden Ramsey over there, maintainer of QGC. Then we got Jaeyoung Lim. He's the maintainer of PX4 simulation. He's not here. Julian O's, maintainer of Mav SDK, and if you've ever asked a question on the forum, it's probably been Julian who's responded to you. And last but not least, our master of docs, Hamish Schwilly.
And everyone, give it up for Jake as well.